Hello, so another help request on exercise 8.2, and so this is our TXY phase diagram using Rails law. Again, the subtlety in this question is going to be, we're going to use fsolve to solve for y and t, and so each time fsolve guesses a value of t, we need to call our int1 expressions to calculate the vapor pressure of both components with that t. Okay, so let's take a look at the code I received and go from there. Okay, and so I received this script in a function. Okay, and so a script, let's see, so the script just sets up the matrix of Antoine constants and gives the pressure of interest and then calls the function. So this is good, right? And so I'd always recommend, well, you know, I would recommend including scripts like this if you have a function with inputs. That way when you submit it to me, I make sure I can run it and it works as you want it to work. Right? Not just submitting to me. In the future, if you're passing these things on to, say, your friend, that they can do the same. All right, so let's take a look at this here. So that matrix of Antoine constants and pressure in kilopascals is inputted. Create a vector of x1 values that we'll loop over. Use size of y1 and temperature vector that we'll collect the results in. This is TK, so I'm assuming this is temperature in Kelvin. Okay, and so I note this because when we do our Antoine calculations, we want a temperature in degrees C. I'm going to loop over x. I have my rail to error function that has ant x1n big Y, okay, and this is going to be the one remaining input, so it ought to contain y1 and t, and pressure in kilopascals. So I'm passing these constants or these parameters to my error function. So let's go take a look at that. So I look at it's rail to error txy, rail to error txy. And x1y and x1y pkpa, just make sure the order is right. So I unpack y, so that's good. psat, so I pull off row 1 for component 1 and row 2 for component 2 for my Antoine matrix, and also pass temperature in Kelvin. So let me look at Antoine. Where are you, Antoine? There's Antoine. So within Antoine, I unpack my vector of Antoine constants. So this is just one note that comes to mind from doing this so often. The Antoine expression that we're provided uses temperature in degrees C. So let's see, is that noted up here? Yeah, T is in degrees C, and pressure is in millimeters of mercury. So the one thing that comes to mind is up here, right, we can use TK, but then let's convert temperature from Kelvin to C. So I'll do TC is equal to TK minus 273.15, and then just replace TK with TC in there. So that's good. So then we compute vapor pressure of both components. P pascals is equal to P in kilopascals. Okay, let's look at this. Alright, what is... Oh, that's the temperature. So you solve for pressure in millimeters of mercury, and then we convert. So you're returning pressure in pascals. Now the units of pressure really don't matter as long as your vapor pressure and your actual pressure, which was inputted on the script, as long as those have the same units. Okay, but we can leave pascals for now, that's fine. So you convert your pressure from kilopascals to pascals. Your psats are given in pascals. To find y2 and x2, that's fine. Your error functions look good. Then you pack it up. That looks good, right? So all we did, right, so far is convert your temperature from Kelvin to C in the Antoine expression. Okay, so let me go back up. So your error function looks good. We have initial guess of Y. Let's see, initial guess of T. Okay, so you're solving for Tsat 1 and Tsat 2. Hey, that's cool. And so with that, then we're calling temp ant. So temp ant must be you solving your Antoine equation for T at that given P. So you're converting your pressure now in kilopascals to millimeters of mercury, then plugging that into your Antoine equation to solve for T. Okay, now one note is, remember, this is going to be our temperature in degrees C. Okay. So let me call that, T naught or TK naught, right? That's in Kelvin. And let's convert temperature to, so this is the average of the two. So this is in degrees C, so let's convert temperature to K. Since, again, I'm basing K off of this TK that you're using Kelvin up there. Although now in reality it looks like you're actually using Celsius throughout, but since I'm on it, so let's do T naught. Okay, so this is my temperature in degrees C. So let's do T naught, which is in Kelvin, would be Tc naught minus 273 plus 273.15. Okay, so I have that. Then I solve. Okay, then first element of my y1 vector is res1. Okay, so here's an error. Maybe this was causing your mistake. This should be tkn, right? Tk is a vector. You just had tk, which meant tk was ultimately just going to be a scalar, and it would just have that final value from the last time you ran your code. You have your reference data. Good, which gives you txy. Okay, and that's temperature in Kelvin, so I suppose it's good we converted to Kelvin, so everything's in Kelvin. But otherwise, that looks good. Looks good to me. Okay, so I'm just going to save that. Here's our rail caller. Let's minimize it. Let's run this animal. Okay, so we get a plot. Our plot looks good. Okay. Answer, looks like we get the last data point. So there's also a question about what's getting returned. Well, if I look at res, so this is, I guess use of having this buzzword res. So I look at when I get to end, and what's stored in res is just that last time I have my last fsolve command. So then if you wanted to, what you could probably do is pack everything up. So if my ref data is packed up in a table like this, where it's txy, okay, what I could do is I could pack everything up in a similar way. I could do res. So now your temperature, T up here, well, x is going to be a row vector, so T and y will be row vectors. Okay, so if I want to take my row vector, make it a column, okay, then I'm going to transpose it. Okay, then my next column, comma, will be x1 followed by y1. Okay, and now I'm just going to peek up here to make sure I have these right. TK, big X1 and little y1. TK, big X1 and little y1. Yeah, so now I've transposed my row vectors to column vectors and then stitched them together so that I form a table, right? So this matrix that you have for your reference data, which essentially looks like the table presented in the problem, so that your data is nicely organized. Okay, so now if I save it, okay, and I'm going to maximize my command window so you can see me call it and see the results. So if I clear my screen, and yeah, instead of storing it to answer, let's just say, R, right? My real law predicted data is txy caller. Oop. Oh, Okay, so my issue now is, let me minimize this. So if I bring up your txy caller, this is just my script calling my function. So what I'd want to do is here say, assign the results of rail txy to, say, variable r. Okay, so that gets saved. Now I can maximize this again. Okay, because now it's just a script. So I just want to execute the script, which will assign the output of that function to r. Right? So now I get my plot. Then r will contain, a nice matrix, just like you had tabulated the reference data. All right, beautiful. So that's it. So it looked like, in terms of what did we change, or what needed to be fixed, the biggest issue was just in your for loop. Here you just had tk, and so yeah, you used zeros up here to create a vector of tks, but then what you're doing down here is you're just assigning a scalar to variable tk. So at the end of your code, all you should have had stored in tk was a scalar value, a single value. Right? TK should be a vector of length 1, right, in your old code. So all we did here is update it so it's properly collecting the data, just like you had done for y1. Right? I think that's essentially the main change. The other thing that should have affected the numerical value was just here in your Antoine function, making sure we're converting our temperature from Kelvin to degrees C, since your Antoine expression uses temperature in degrees C. Okay, but that's it. Hopefully that gets you going and helps you solve the problem.